Hi, we're going to take a look at the Red Pitaya, a roughly $240, not quite a USB oscilloscope. It's more of like a high-performance data acquisition system. Thank you very much for Red Pitaya for sending this one in. I actually got this in the mailbag a little while back, along with an analog discovery. And I thought I'd do a video actually comparing the two, but I've already done like a fairly in-depth video on the analog discovery board, and it's very similar to the Red Pitaya. So I thought we'd just have a play around with the Red Pitaya today and see what we can do with it. See if we can get a bode plot and just basically set it up and use the thing. And here it is inside the optional aluminium case. I highly recommend the aluminium case. It is very sexy indeed. And we've got a bunch of high-end hardware in here, and we'll take a close look. But of course, the main grunt in this thing is provided by a Xilinx Zinc. This is the 7010 system on chip series, and the Zinc processors / FPGAs, because that's what they are. They're fairly unique in that they have not only a ARM Cortex A9 in there, plus Xilinx Artex FPGA fabric as well. Incredibly powerful beasts. These are not cheap devices, and this is actually running embedded Linux on this thing. I'm not sure what particular flavor, but we've got 4 gigabit of DDR3 DRAM here. Basically, we've got 1 gig Ethernet over here. We've got micro SD card, we've got USB, and we've got 2 USB connectors on the bottom as well. One's for power and one's for serial command type interface. And we've got a bunch of LEDs along here. There's a JTAG port, and we've got a bunch of user I/O as well, which if you use the aluminium case, unfortunately you can't access, but there's like another clear case version where you can access these. And there's an additional 12-bit, I think 100K sample per second multi-channel ADC in here, and various I/O, so you can control everything. And this is basically not just a USB oscilloscope. It's much, much more than that, just like the analog discovery one. It is basically a complete DAC, a DAQ, a data acquisition system, basically with dual channel 14-bit 125 meg sample per second converters, dual 14-bit DACs as well, and a whole bunch of I/O, and running embedded Linux, Ethernet. You can basically, yes, you could use it as an Internet of Things, in quote marks, device, and it's basically a programming system, kind of like the, like the Raspberry Pi kind of thing. It's got a visual programming environment, which we won't really take a look at in this thing, but it's got, you can do FPGA development on it inside the Xilinx Zinc, and you can just use it as a generic USB oscilloscope if you want. You can use it as a frequency spectrum analyzer, you can use it as a network analyzer, you can use it as a software-defined radio, because it's got like a 50 megahertz analog bandwidth, so anything up to 15 megahertz at 14-bit conversion, yeah, it's going to make a decent software-defined radio. It's web-based interface, so either my one actually came with a Wi-Fi dongle on it, or you can use the Ethernet. You can program and operate this thing remotely from anywhere in the world. You can script it, you can do all sorts of things, and apparently it's open source, at least open source software. It's the 7010 series system on chip. This is not a cheap part at all, especially in one-off quantity. Here's our analog inputs here. So here's our ADC. It's an LTC 2145. This is not a cheap part. It's almost the same price as the Xilinx Zinc. It's like $50. And one-off, DigiKey type price for that puppy. And the performance is absolutely stellar. I'll link in the data sheet down below if you want to check it out. So that's dual channel 14-bit 125 meg samples per second. The DAC here, here's the 2 DAC outputs, also 125 meg samples per second, 14 bits as well. That's about half the cost. That's about $25. So if you're wondering why this thing is so expensive, well, there's a fair bit of expensive chips in it, and unless you manufacture 1,000 of these or 10,000, it's going to cost a bit. And for those who want to see the bottom, there we go, peekaboo. We've got all our bypassing on the bottom of the Zinc there. Tiny. They're little 0402 jobbies by the looks of it. Absolutely tiny. We've got some line termination stuff here, and a few miscellaneous things. There's our USB. We've got some protection on the USB power input there. Looks like we've got a poly switch, and it looks like we've got a programmable attenuator on the front end here. And we've got two, well, SATA, well, they look like SATA connectors, and they are SATA connectors, but they're not designed for SATA. These are synchronization connectors, and I haven't looked into the details, but presumably you can sync up the acquisition for big, between boards, for like daisy chain them for big multi-channel stuff, but that's just a guess. I haven't even looked. So that's the Red Pitaya hardware. And yes, it is a red solder mask. I love it. Beautiful. One of my favorite solder mask colors. Red. Makes it go faster. Anyway, let's take a look at the software. See if we can get this puppy up and running. See if we have any grief or whether it's just going to work like a treat out of the box. Alright, let's see if we can make this Red Pitaya do something useful. Now, I've come to the website here. This is my first time using the thing. I don't have any instructions, didn't come with it. At least my one didn't anyway. It's just the brick itself and the website. So let's take a look. Now, I have actually had a look at the website, and it actually confused me for some time exactly what's going on here. I mean, you play the video here, and it tells you all about this visual programming, visual programming system and things like that. So, like, I don't want to program this thing. I just want to use it as an oscilloscope, as a network analyzer. Get a bode plot or something like that. So how do you do that? Well, I couldn't immediately, we can browse some apps here and we can do some other stuff, an application marketplace, and it has all this, weird and wonderful stuff, but it actually took me a little bit, maybe because I'm a bit dumb. You go up to the start here and you can go to the quick start. So this is actually a nice step-by-step process. It's, look, step number 1, prepare the SD card. Mine already came with an SD card, so I presume that they are preloaded and everything for me. I don't know if the one that you will buy will actually come with a preloaded SD card or not, but look, you can download the image. It's got instructions for Windows and for Linux and everything else. So, you just download it and it creates a bootable disk image that contains Linux and everything else. Fantastic. And how would you like to connect? The cable connection or wireless connection or direct wireless connection. I'm going to go for broke here, and I'm going to go for the wireless. I'm going to plug the Wi-Fi dongle I got in here, and here it is. Enter your wireless information and download the configuration file. Now it doesn't tell me, I presume wireless networking information. I'm presuming that's the name of my wireless network, and that's the password. So I'm going to give that a go. And it generates a file, and you can download. You put it on the SD card, and presumably Bob's your uncle, and it should blink at you when we're done. Let's give it a go. Alright, so I downloaded and copied my file. There are 2 USB connectors on here. You have to plug it into the power one, not the cons. I assume that's console, like a serial console type thing. So I've copied the file. I've got my my Wi-Fi dongle plugged in. It came with it, so I'm not sure which one you need. And there's an LED on there, and it's flashing, and it's supposed to, after 30 seconds or so, so we're going to have to wait, it should eventually be green and flash red. And I can kind of see, oh, there it is. It's like a heartbeat. I think we have a winner. So here we go. Step number 3, connect to your Red Pitaya and make sure it's connected to the internet. How can I make sure? I don't know. That's another fact thing which I don't want to read yet, unless something goes horribly. Oh, no, look, no, I don't want to do command pings. No, bugger that. I just want to input my MAC address and go, let's start. Got to create an account. Thumbs down. I guess that one could be useful because then you can access it from anywhere, and I don't know. Anyway. And bingo, we're in like Flynn. Check it out. I just registered. It didn't have to make me verify my email, so beauty. It just took me straight in, said thank you for registering, and I put in the MAC address and the EEVblog, and there it is. there's my LAN IP address that I can go directly to it. Presumably, unlocked applications, oscilloscope plus signal generator and spectrum analyzer visual programming license. I don't have a license for this visual programming thing. I don't want to, you won't see me do that in this video. I'm not really interested in that. I just want to use it as a, spectrum analyzer, oscilloscope, everything else. So, yeah, we're in like friend. Unlock apps. Can we have a look at unlock? I don't know. Unlock code. Got no idea. It should just connect to the browser. Remember, this is Wi-Fi, so I'm not connected to the Ethernet at all. There it is, and that's my telephone. Well, that didn't work. Not directly to the IP address anyway. So anyway, let's just hit start. No, it doesn't like it. Fail. Gee, is this like a Wi-Fi access? I mean, it can see it. Right? It can see it. Tells me my LAN IP address, everything. Like if I have to go in and create gateways or some other crap, I don't know. I'm not some network penguin guru. Yeah, no, it just doesn't work. Fail. See? Stuff like this just really, it leaves a bad taste in your mouth. It doesn't inspire confidence at all. It might have just worked if I plugged it into the Ethernet. I'll try that. So there we have it. Got my Ethernet plugged in. We've got that red heartbeat double flashy thing. So, yep, I'll go through the process yet again. And it wouldn't let me add a second device because the MAC address already existed, and I just clicked on the IP address here. Presumably do the same thing if you do start. Yes, it is. Start button is the same as that. And ta-da! We're in Lake Flynn. So, sorry, I have no idea what happened to the Wi-Fi thing, some DHCP thing or something maybe. I don't know. Everyone who knows all about networking is probably screaming at me now, oh, that's obvious. But, hey, it didn't work for me. So, what am I supposed to say, right? It didn't work out, didn't work off the bat. So, not impressed at all with that Wi-Fi setup. So, anyway, works with the Ethernet. So, beauty. Visual programming, which I don't want to do that in this. Oscilloscope Pro and Spectrum Analyzer Pro, and we can get more applications. We can either do a demo or we can run it, run the real application on the real hardware here. So here's more, look at this, Tesla meter, 2-channel time domain signal visualization system. Cool. Oh, PID controller and oscilloscope, look at this. Okay, frequency response analyzer, very, very nice. AKA, it's a Bode analyzer. Well, frequency response sort of Bode plot. And impedance analyzer requires a shunt resistor. There you go. It's even got a link to a guide available for that. Okay, so these are the official Red Pitaya apps, and then we've got contributed apps because that's the whole thing about this. It's open source hardware. You can actually it's it's all available. You can write your own apps and everything like that. So these are community developed apps. It's got an SDR transmitter, SDR transceiver. Sorry, because it's got a signal generator and a oscilloscope / receiver as well. And it's a full 50 megahertz, up to 50 megahertz or so, I believe, is the bandwidth SDR or software defined radio. So there you go. Good on you, Pavel Demon. And LTI DSP workbench. Oh, that's interesting. It's another spectrum analyzer, SDR transceiver, another SDR app. I think this thing could be, a fairly big and useful device for the SDR community, at least up to 50 megahertz or so. If you're up to the, the real, the high frequency stuff, then it's no good, obviously. But anything below 50 meg, it's probably going to do the business and do it really well. At least it has the hardware to do it. So it all comes down to the apps. Calibrate, upgraded with DC offset, calibration. Oh, you can calibrate your thing. Anyway, I'm going to install a Bode plotter. Here we go. Does it work? It's spinning around, spinning its little gear wheel there. I assume it downloads the app to the Red Pitaya. And because obviously it's got to run on the hardware itself, because it's got to utilize the FPGA and stuff like that. So it's got to program things in there. So yep, okay, it's installed. I'm going to install them all. So I haven't actually used it yet, but I'll tell you what, I'm liking this a web-based app model interface. It looks like it's really jazzy, doing the business here. So quite impressed by that. It's their bazaar, so it's the apps are available at the bazaar. There you go. So how do we get back to our IP address? Ta-da! There you go. There's all our apps which we didn't have before. Awesome. Look at that. So our impedance analyzer, that's basically an LCR, well, as it says on the icon there, LCR meter. And we can, obviously we won't see anything here. I need to make up a little jig with a shunt resistor in there, because it basically measures the voltage from the generator and then the voltage across the device under test in series with a shunt resistor, and from those two voltages you can calculate the impedance and everything else. You can calculate capacitance, inductance, resistance, everything else. You can draw the response and do the whole thing. I've done a video on that if you want to know how to actually calculate those sort of things way back, like episode 30 or something crazy like that. Anyway, so we can go in, and this is all web-based interface. I'm liking this. It's quite neat. All right, Oscilloscope Pro is the one that came with it. I'm not sure why they wouldn't install all the official ones as standard. I guess maybe they don't want to confuse people. They just want to, here's an oscilloscope, here's a spectrum analyzer, that's it. Just fair enough. And here's our scope. We're in like Flynn. And one thing to note, this thing actually does get quite warm during operation. I'm not actually doing anything, not sampling. Well, I guess I'm running the scope app, but yeah, it gets reasonably warm, not overly hot. So as you saw, it's got the heatsink there on the top of the case, which goes down, presses against the Xilinx Zinc processor inside this thing, which is a really powerful beast, running Linux, high efficiency as well. It's fairly high efficiency, but still it's doing a lot in there. But yeah, so it's getting reasonably warm, but still, in the scheme of things, it's drawing like bugger all power for, a ridiculously powerful instrument like this that you probably couldn't even dream of getting 5 years ago, by the way. Absolutely amazing. Now, I'm not sure what's going on here. I went in channel on, but I had the channel there before, and now it's gone, and I was playing around with the output, and here we go. I can select various output waveforms from the generator, and like I don't know, I tried to type in a higher frequency here, press enter, and everything, my waveforms seem to have vanished. Show, unshow, it's like stop, run, I don't know, like something's like auto scale, nothing, my waveforms have gone. Not sure what's going on. No, but it's still got, can we drag that? Oh, we can drag the offset. That's nice. All right, but that's, it's exactly what you'd expect. So let's turn our SIGGEN on. There we go. Bingo. I've got an input-output cable connected between channel 1 and 2. We're in like Flynn. There we go. What's the green? Oh, the green is the second input channel. We don't really want that. How do we turn off the second channel? See, like it's stopped updating. What's going on? Like, it's worked. It's captured something, right? But then it's just, hey, there we go. Look, it's gone. What the? Select my, no, something is, there it is. Something has gone wrong. Is there a problem with the server? I don't know. What server? I just got a router. I've plugged my box into the router here, and which is the same router that my PC here I'm using is plugged into, so, it's not like it has to go halfway across the world or anything. I got no idea. What the photon's going on? And we're at 1 volt per division at the moment. I don't like this control over here, which adjusts your thing. I'd rather have like a separate knob or buttons for each channel and stuff like that. So anyway, if we increase that, look, 500 millivolts per division, okay? So we're going down, so that's all hunky-dory. But it froze last time I did this. It actually froze. So we can change our time base to 2 milliseconds per division. There we go. What are we picking up there? That's interesting. because that's our channel 1, and that's fascinating, actually, because I've just connected, as you saw, the output of the SIGGEN to the input of this, and it's the SIGGEN is turned off. So, yeah, quite strange. Anyway, we can turn our SIGGEN on. There it is. Hey, got some alias in there. Doesn't like that. It seems to be more stable now. It seems to be doing the business. So, I don't know. It's fairly responsive. There's a little slight delay when I click that button, but not much. It's pretty good. And the waveform quality is brilliant, as you'd expect with a 14-bit converter. It looks like it's doing the business. Now, here we go. Here's a worry. I'm going to select channel 1, and I'm going to go auto scale. It works. Yes. Beauty. Channel 2, we can turn off channel 2. Yeah, like, there's plenty of room on the screen here to have all these settings, right? All of these settings here, all on the screen, and all the controls. Why I've got to actually select number 2 and then go into a setup icon thing, it's dumb. No, that's just poor user interface design. Sorry, anyway, look, it's frozen again. Something like this. Someone with network experience to go, oh yeah, I'll just go in with my penguin skills and go into the command line and, try and figure out what's going on here. But I've got, no idea. Dummy user like me, it just freezes on me. What am I supposed to think, right? It's not a good impression at all. Anyway, here we go. We're generating a 10 megahertz sine wave now with the SIGGEN here, and as you can see, our sampled waveform in yellow there is, well, not that great, because this is, well, it's 125 meg samples per second, so we're getting our 10 samples per division, but there's no sine, presumably no sine, well, doesn't look like any sine X on X interpolation here. It's just got linear interpolation, so, and there's jitter, we're getting so our trigger is currently set to channel 1 input. Yeah, I mean, we could probably external input. Actually, where is the external input on this? It might be on one of the internal expansion headers or something like that. I did not show you this because I had my position thing. This is the thing I was talking about before for the our vertical and horizontal control down here. Oh, down here. Yeah, I don't like the control. As I said, like all this wasted space around here. Look on the left-hand side, on the right-hand side, and we've got this dinky little, gear setup icon thing. No, just no. Fail. No, there's plenty of room in here to put everything you need. So I think they really need to update the user interface with that thing. Anyway, settings, we can do calibration. Haven't tried that. Anyway, that's kind of what I would expect. Of course, we're seeing single sample jitter there, so I don't think we have any other options in there to actually display to change our interpolation, do averaging or nothing or anything like that. So it's a very basic oscilloscope. Now, here's the thing. Actually, the Red Pitaya is supposed to be open source. They're, promoting open source, blah, 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 open source software. Yeah, but not open source hardware by the looks of things. And I couldn't find any schematic on their webpage at all. And when I actually Googled it, the first hit was actually the Red Pitaya schematic, was actually the EEVblog forum, and somebody, London Doc, is very disappointed at the refusal to release full electrical schematics for the supposedly open source project. My guess is they want to keep imitators from generating similar products. Fail. So yes, if that's genuinely the case, that is a big thumbs down for not releasing the schematic. I presume that they've got all of the source code for the ARM processor plus the FPGA and stuff like that, because you can actually do FPGA development on this thing. Not only is it designed as a general purpose oscilloscope, it's designed as a coding tool and things like that, but it's also designed for FPGA development because it has that Xilinx Zinc FPGA in it, and you can do that. They actually ask you when you register, what do you want to use it for? Do you want to use it for, as an oscilloscope? Do you want to use it for FPGA development or whatever? So yeah, presumably they've got that. I don't know. I haven't looked into the source code and everything else, but yeah, you can do remote control using MATLAB, Python, LabVIEW, Scilab. It's got, if you really want to get down to the nitty gritty of integrating this, integrating a scope or a DAC. It's effectively what this is. It's a data acquisition, module. Then, yeah, this this thing could be the duck's guts for doing that. If if it suits all your hardware specs. It's got dual converters in it, synchronous sampling. That's how they can do the LCR module, the impedance analyzer module. They actually sample them at the same time, otherwise you've got issues. So it's got dual sampler in there. It's got a secondary sampler on the I/O headers internally on the thing, 100k samples per second at 12 bits, so that's not too shabby. You can do some useful stuff with that as well. And they're trying to compare it to the Raspberry Pi and the Arduino Uno. Not really the same thing, but as I said, they're trying to sell this thing as like a programming platform, hence all the visual programming stuff that they're actually talking about here. You make your own web-based apps and all sorts of weird and wonderful things. But anyway, visual programming, there it is. Buy now. Do I have to buy the visual programming interface? That's a bit disappointing, but I guess they've got to make their money somehow, although I'm not sure how much they're making on this board. I haven't done a BOM costing, but it's not a cheap board by any stretch of the imagination. Oh, they've got an LCR meter extension board. Oh, I wish they would have sent me one of those. I'm going to have to build for $300. 300 euros? Wow, will be available in 30 days. It's on back order. 300 euros. What's on it? It's just got a pick. That looks like a pick. With some shunt resistors and some relays. They look like little Pickering relays. If they are, very nice. I'm a bit of a Pickering relay fanboy. I like the fact that they're red. I've never seen them in red before. Wow, they're little compact single inline ones. They're probably magnetically shielded as well. You can get magnetically shielded options in the Pickering relays. Anyway, very nice relays. I have extensive experience with those. Geez, 300 euros for an LCR meter board. Wow. Geez, that's pretty rich. Anyway, while we're here, let's take a look at some other stuff. The aluminium case, which I've got, which I highly recommend it. Yeah, that's available for 39 euros. That's an optional extra because normally it's just a bare board. Clear acrylic case. That's a cheaper one. I don't know. I like the... is that a... Oh, no, that's just a vent hole. Oh, a fan. Okay, it looks like you can screw a fan on the top of this thing. No, the aluminium, if you're going to spend the extra $10 and get the aluminium case. So the Red Pitaya board itself, by the way, is 199 euros or Yankee bucks, 238 Yankee bucks. It might sound expensive for just a board, but the Xilinx Zinc processor in it is not cheap. I think if you go cost that one off, it's probably like $100 for the chip or something. Don't quote me on that, but it's not a cheap chip. No, you get a lot of bang per buck in this thing. I think it's worth the money. It is worth the money. I like the app concept and things like that. It's a shame it's not fully open source, or it doesn't appear to be. That's a real bummer. But yeah, I mean, you can develop all your own apps, so all the SDK and everything, the programming, all the source code and everything's available. But why not give us the hardware? Jeez. And they want a lousy $6 for the visual programming system. Oh, free, and you can get a free trial for 7 days. Play with it. Not sure why they bother selling it at €5 a pop for why it's not included, but I can understand it's probably a lot of effort to develop a visual programming interface, and it kind of looks all jazzy. But yeah, I don't know. I might have to save that for a separate thing. But if you're really into programming and getting apps up and running real quickly, the problem with these visual programming interfaces is that they're non-standard. So yeah, here it is, like do repeat loops. Here we go, and put command rotary LED, so you can do various things. Really easy for getting apps up and running real quick, but ultimately useless like skill to learn if you want to actually program something else. So, but it allows you to, it's kind of like National Instruments LabVIEW, for example. Really incredibly powerful visual programming environment, but it's a skill. If you learn that, that's it. Like, it doesn't translate to any other product at all. It's why I like, bench oscilloscope. Plug it in, turn it on, works, But granted, this is not a replacement. I keep saying this, USB oscilloscopes are not replacements for bench oscilloscopes. They have their niche uses. In this case, it's not really just a USB scope. If you just want a USB scope, go buy just a USB scope. You probably wouldn't just buy this. It's more useful when you want to do really clever stuff with it. You want to automate something. You want to design an automated web interface that'll tweet when you signal goes out, when you get a signal or something like that, or do whatever. You can interface digital stuff to this. You can do all sorts of things, program it. Fantastic. If you want to use it as a software learning tool, an FPGA learning tool, that's what it's good for. If you're just using it as a USB scope, obviously you've seen it, right? You've seen the interface. It's no good. It is like, that's a hopeless USB oscilloscope. It works, but, it doesn't offer you any, bells and whistles at all. Okay, if we go in here and run another app, the frequency response analyzer, all these apps are pretty basic, I've got to admit. Not terribly impressed with them. Here we go. Now, this one I haven't actually plugged the thing in, so let's actually plug it in. This is showing the response over the full range. So if I plug that in, there we go. That's pretty horrible, which is why we have to calibrate the thing. Let's turn channel 2 off. There's channel 1. Look at that. Wow. Why it's that horrible? It's by default, it's going from 0 to 60 megahertz. It'll be sweeping over that range, and we can calibrate. So if we hit the calibrate button, yeah, okay, it's reasonably flat, but look, it's all over the shop. What the photon? Look at this. You see it rolling off there at the end, but what, like, this is like gain, like, a couple of dB here. Like, it's horrible. What's going on? I don't get it. How can it be that bad? Yeah, so that's a real dinky app. I mean, all you can do, error while sending data, E3, what the, restart, what the, like, come on. Wow, this thing is flaky. Is it just me, or is anyone else having issues? I mean, like, wow, why this needs to be, why it's out by that much over the frequency range, I've got no idea. Anyway, it really is quite dinky. I mean, you can zoom in on parts like that. Okay, that's fairly good, but that's basically all you can, that's basically all you can do. You can reset the zoom. Oh, no. How do you reset the frequency? We can scroll with the frequency, but, like, it's a real, like, really basic application not loaded. What is wrong with this thing? Anyway, if we go back, wow. It's not like I'm over Wi-Fi with some dodgy connection or something. I'm connecting directly with Ethernet with this thing. Anyway, we'll go into the Bode Plotter app. And this is very Spartan as well. I had a quick play with this before, and it's like range settings. Measurement settings. Look, amplitude. Like, if I want to go point, if I want like 10 millivolts amplitude, if I want to get a, generate that. Like, what the, like what? Start measurement, blah, 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 measuring. And, like, it's just a real dinky app. Don't like it. And here's the other oscilloscope app. Instead of the Oscilloscope Pro, this one can do averaging. Look at that. No wuckers. But, yeah, like, no, the user interface just, no. no, don't like it at all. Why should I have to scroll that list? Why can't it make use of, once again, user interface, make use of all the screen, just have the links there. Like, you know, why it even has to be fancy like this? Why this can't be like a text link or something, you know, like a basic HTML page or something? Why it has to be all fancy-pantsy like this? I don't know. Whatever. Spectrum analyzer. There we go. We haven't had a look at the spectrum analyzer yet. Let's go in, have a squiz. That's really quick update in there. How do we set all of our... where are our settings? Frequency. We can have our frequency range, but... like, where is our number of bins? You know, where can we set the number of bins? Where can we set the window in? Where can we set... I see auto scale. I see reset zoom. I see an incredibly basic app. Wow. Wow. No. No. No, that doesn't cut the... where? No. How do you set it up? You can probably zoom in. Okay. Whoop-de-doo. Nah, where's all the settings? What do you want me to say about that, really? I mean, no. Generator and oscilloscope. That's the thing I wanted to test. Like, how can you set the generator running, for example, in the background, and then go use your oscilloscope app, for example? Is that possible? Or do you need an app like this one, which has generator and oscilloscope built in? Now, this looks like the oscilloscope app we had before, but it's got the extra signal generator down below. So there you go. We can, looks like in file you can upload files, so arbitrary wavegen, but yeah, this is not... no, the apps are not impressive. The hardware I really like, the sort of the way that they've done it with the web-based thing and the apps and everything. I do like it, but the apps leave so much to be desired. Let's hit the auto button. Hey, there we go. It popped up. That's our gen. That's a dinky toy interface, that is. There we go. I can use the mouse wheel. That's pretty good. No, I'm not impressed with these apps. Not impressed at all. Sorry, Red Pitaya. No, more work required. And of course, one of the things I really wanted to do with this thing is get a bode plot of my microcurrent, like I did with the analog discovery before, with great ease. But like this bode analyzer here, it's just like, look, it's not even, look, starting frequency, 1 kilohertz, there it is. But the actual graph here starts at like 0 hertz. There's 1 hertz, 10 hertz, 100 hertz. Like, what? Like, it's just ridiculous. And why is this, like the amplitude, I want to set 10 millivolts because microcurrent has a gain of 100. I can do this easily on the analog discovery. It works a treat. This thing's just hopeless. Start measurement. Like, it should go do it, sample, sample, sample. It should draw your bode plot like that as it sweeps the frequency. But no, I mean, I've set it to start at 1 kilohertz. Yet, what, is it starting at 1 hertz? What? This thing doesn't work at all. It's useless. There you go. It's just sitting there locking up. Surely I can't be the only one having issues with this thing. Oops, silly me. With the Spectrum Analyzer before, I was not in the Spectrum Analyzer Pro. I was just in the regular Spectrum Analyzer. So that's it. But once again, look, right, it's not generating a signal. Like, I had used the generator app before to actually generate a signal, and now it's gone. Like, you change the app and it, like, I don't know, reconfigures the FPGA hardware in there, and it's gone. Like, unless you specifically write an app which has both functionalities built in, and I don't like that at all. But once again, this is supposed to be the Pro Spectrum Analyzer. Okay? Where are all the settings? Where's your number of FFT bins? Where is it? Where is it? There's nothing there. That's bare bones. Its performance is actually probably going to be quite reasonable with the 125 meg sample per second 14-bit converter. I have no doubt that it would be reasonable, but the app, this is the Pro app, right? This is the Pro app. Where are the settings? Nothing. So much for Pro. That's just, nah. That doesn't cut it. I'm sorry. It's, you've got to have impressive default apps for something like this for people to use. I know it's more of a, it's probably, more of a programming, learning type tool than it is, like a real off-the-shelf useful tool, like out of the box experience. A better out of the box experience by far is the analog discovery one, which I've done a video on and people have asked about before. The out of the box experience of that one completely blows this one away. But the Red Pitaya is inherently more powerful in terms of stuff it can do and things like that. Not that impressive. Sorry, Red Pitaya. It has great potential. I think it's really good if you want to go to the effort to write the app and things like that. I think it could be a incredibly powerful tool and a big winner for you. And I like the app interface, and I like the way that they've done it. The quick start thing, it all seemed to work apart from the Wi-Fi thing. Very disappointing. I don't know why it's locking up, but it seems to be working now. And issues with it, but the apps just don't cut the mustard as an off-the-shelf tool. Sorry. Nope, not hugely. So impressed with some things, not hugely impressed with others. So you're going to have to weigh up whether or not it's the tool for you. If you want an out-of-the-box experience with a good USB scope and spectrum analyzer and everything like that, the Red Pitaya is probably not for you. I'd recommend, if you want out of the box, I would go for the analog discovery, which is a similar price. I think it might be a little bit cheaper, but it's not as powerful as this. I think the specs of the Red Pitaya are superior. So there you go. That's a quick look. I will no doubt play with it some more. I want to do the LCR meter functionality, which I didn't get to look at. Where was it? Impedance analyzer. I didn't, plot settings. I'm going to have to build up a little, it's not hard, just a 50 ohm resistor in series with a device under test, things like that. But I'll try and do that as a separate video, because that could be quite useful. I want to, get impedance responses of various components, capacitors for bypass applications, inductors, things like that. So that could be quite useful for, network analyzer stuff. So I'll have to do a separate video on that one. But there you have it. That's the Red Pitaya, which is kind of, sort of working for me. Might have to get on the forum. Anyway, hope you like that first look, I guess first impressions, because this is just me first playing around with this thing. And I think it has potential. But, it needs a bit of work. Catch you next time.